Hello, and welcome to this tutorial. This video will show the basics of how to create a block diagram, or BD, create a Zynq processor, and use a serial port for FPGA communications. We'll be using the Trenz TE0720 SOM that hosts a Zynq 7020 FPGA with the TE0706 carrier board. A Zynq is made up of a processing system, or PS, and programmable logic, or PL. The processing system is equivalent to having an ARM processor on the same silicon as the programmable logic. The ARM processor has several connections that are hardwired with no PL intervention. In this demo, we're using the UART that's directly connected to the PS for serial port communications. Okay, so to start with, we're going to launch Vivado, and we're going to go File, Project, New. And you can browse to the location, use the Xilinx directory, name your project. I'm not going to specify any sources, so you can just leave this at the defaults. And in this case, we're going to choose boards, so that it'll pre-populate a lot of the interfaces and pin out for us. And then select the board that we're using. I have this one with the 7020 on it. And that's going to create our project for us. Okay, so the first thing we're going to do is go ahead and create the block design. So I like to call this Zynq one. Sometimes I do microblazes, whatever your processor is, or you can leave the default, whatever you like. So in this case, we're going to go ahead and add, and this is a search utility, so you can go ahead and search Zynq. In this case, this part has a Zynq 7, so we'll double click that. The run block automation is going to be your friend here. So it's going to have the apply board preset selected, and this is going to lock down a lot of the fixed I/O, the DDR, things like that. So you can just go ahead and accept the defaults and say OK here. What we need to do now is go ahead and create the reset. So this is going to be a synchronous reset. We'll make it external. I'm going to go ahead and take the fabric clock and make that external. And then I'm going to connect this AXI clock to that clock. Now what I want to do is I want to see what this clock frequency actually is. So I'm going to double click on my Zynq. And one thing you'll notice is because we have a board preset, if you look at the peripheral I/O pins, a lot of these things are already mapped. And for our demo, UART 0, you can see it's already mapped to MIO pins 14 and 15. If you were to look at the schematic, those pins are hardwired on the actual FPGA. In our case, I want to see what the clock frequency is. So I'm going to go to clock configuration, PL fabric clocks, and my clock is 100 megahertz. So that's fine for this demo. I just wanted to see what the frequency is. So I'm going to go ahead and select that output, and I'm going to name it just so we know that it's 100 megahertz. And I'm going to save with Control S. And you can click this validate here. This is going to validate your design, make sure that there's no errors in it. So the validation was successful. Say OK, and I'll go ahead and click generate block design. So the next step is going to be to create a wrapper. Now, in this case, if all of our I/O, our external I/O here were going to be mapped, you don't necessarily need to create a wrapper. But when you have a design that has any kind of real programmable logic in it, it's a good idea to create a wrapper so that you can instantiate any of those other components there. So what I'm going to do here is I'm going to go to Sources. I'm going to right-click on the Zynq, and I'm going to say Create HDL Wrapper. Now we're going to let Vivado manage the wrapper and auto-update it. Say OK. And it's going to create our wrapper for us. So I'll go ahead and expand this. What I like to do next is open the file and take a look at it. And what you need to do here is make sure that all of the I/O that are mapped in your wrapper match your HDL. So I've skipped a couple of steps here. What you see in my VHDL entity here are all of the external I/O on the chip to the board. The only two signals that really aren't included in those I/O are the 100 megahertz clock that's for the PL, as well as the reset that's for the PL. Now those don't go anywhere because we don't really have any programmable logic, but once you do have more instantiations, more components here, you can use that clock and reset to handle those. So once I'm happy that my top level is going to instantiate my wrapper, I'm going to go ahead and add that file. So I'm going to hit the, I'm going to right click and say add sources down here, add or create design sources, add files. It's going to default to wherever I created my project. So I'm going to go back. I've got a source directory here with my hardware, HDL. Now, the one piece that we don't have here is you would normally also have a constraints file that would lock down your pinout and specify all of your voltage IOs. We don't need that here because we had the board presets and it already locked down all of the IO. But if we added any other signals here, we would go ahead and add a constraints file. So I'm going to expand this. Notice that it already made my HDL that instantiates the wrapper. It already made that the top level. You can tell it's the top level because it's in bold. If it for some reason wasn't, you can right click and say set as top and it'll change what your top level is. But this looks correct, so we're good to go. I'm just going to go ahead and click generate bitstream. Okay, after that completed there in warp speed, we have a bit stream, so I can go ahead and cancel out of this. Now what we need to do is create a handoff from Vivado that's responsible for the hardware to Vitis that's responsible for the software. So I'm going to go to File, Export, Export Hardware, next, and I want to go ahead and include the bit stream. That way it'll configure my PL. Next, I'm okay with the defaults. It's going to create it wherever I created my project here. So next, finish. And we've now created the, it's an XSA file, which is the handoff from Vivado to Vitis. Okay, so the next thing we're going to do is launch Vitis, and I'm going to create a brand new workspace. It's going to give us this welcome screen. You can go ahead and exit that. And we're going to do File, New, and we're going to do a platform project. So you can name it. And what we're going to do next is we're going to browse to this XSA file that we just created in the previous step. So again, this was the handoff from Vivado to Vitis. I had it in the Xilinx directory. Go ahead and select that. Okay, when it finishes, you'll see the XSA. You can just hit finish from there. Once it completes, you'll have a couple of board support packages here as part of your platform. You'll have the FSBL, which stands for the first stage bootloader. You would need to change that board support package only if you wanted to like route a UART to a different UART port. What's more common is you'll change the standalone board support package. And if you need to change anything there, you'd go to modify BSP settings. And like I mentioned, the thing that tends to come up a lot is the standard in and standard out. By default, it's going to be routed to UART1, which for our case is correct. But in some cases, maybe you've created like an AXI UART that you need to route to those pins that are connected to the PL, or the PS actually has another UART that is hardwired to the ARM pins. So if you needed to change it, this is where you'd do it, and then you'd say OK. In our case, the defaults are OK, so I'm just going to cancel out of that. So now I'm going to click on the platform, right click, and say build project. The next thing we're going to do is create our application. So now we'll go to File, New, an application project. And we're going to let it choose the platform that we just created. So you can just say next. By default, it should select what you did, which already created. I'm just going to name it UART app. And now it should create our application. You'll see a couple options here to select. Now, since we just want to verify the UART, we're going to select the hello world and say finish. Once it finishes creating it, I'm going to expand the source and double click on the hello world.c just so I can see the source code. You'll see this project is actually really simple. It's basically just going to initialize the platform and print a couple of lines. So the next thing we need to do is set up the communication from our PC to our board. So I'm going to go to debug configurations, make this a little bigger, and we want to use the single application debug. Double click that. And if I go to application, you'll notice that it's already pre-populated with the ELF file there, but the ELF file actually isn't built yet. So I'm going to go ahead and close this, and I'm going to right-click on my UART app, and I'm going to build that project as well. So we already built the platform. Now we're building the application that's going to connect to the platform. That should be fairly quick. It'll show you some statistics here about the size of the actual application. If you're running on internal, like block RAM, something like that, a lot of times you'll need to be pretty careful about the size. But since this is a Zynq, we're running on external DDR by default. So the size is not quite as much of an issue. So anyway, I'll go back to my debug configurations, go back to that one that I created here. And now under application, it still has my ELF file, but you'll see this debug is highlighted here. So I'll go ahead and click that. All the rest of the defaults are just fine. And what it's going to do right now is it's going to try to connect from my PC, in this case over a USB to JTAG off to my system on module. And everything went well. It programmed the FPGA, and you can see here it came up to my init platform. So I've resized it here just so we can see the program execution, and we can also see a console port that I have here. So I'm going to use the hotkey F6 to single step through here. They're actually available as well on the run if you need to set breakpoints or you want to just let the application run or single step. I'm going to use F6. It's going to initialize the platform and print hello world. You can see here on our console port, we did in fact get hello world. Here's the second line, prints that out. And that's really it. So I really hope that you found this tutorial helpful. And if you did, please press that subscribe button.